Copy. Prof, cuba klik yang dekat chat tu. Saya dah bagi dia punya link.
Yang chat
Ha.
Dekat chat ke?
Ha, dekat chat tu.
Okey, jap.
Link.
Sini. So ini saya tekan sini
Ha.
Nak suruh saya tekan. Okey.
Sekejap saya nak pergi MYTRIBOS pula.
Ada? Ada dalam YouTube ada?
Itulah. Facebook tak boleh pula lah, terpaksa pakai YouTube.
Ya ke? So saya off balik yang ni sebab ada dua dia interference.
Off yang YouTube off.
Okay. Alright, good. Alright. Okay, cantik macam tu rupanya. Okay. Boleh. Seorang-seorang you handle lah, I respect lah. Kalau macam ini, I tak boleh buat kalau saya.
Okay. Minit lagi, jadi kita start. Tapi dah live dah ni.
Live dah Kita dah live saya kena baca you punya ni jap. Saya kena baca you punya apa tu? Yang mana tadi?
Link tu Prof boleh bagi kot dekat MYTRIBOS punya link. Link tu boleh bagi kat MYTRIBOS kot. Saya dah ni. Saya dah pastekan dia punya tu.
Okey, saya kena mana tadi yang saya dah buka ni? Mana beri tu?
Tak apa, betul. Dalam yang MYTRIBOS tu saya ada bagi dia punya link dia.
Tapi sebab saya nak tu. Saya nak buka yang you punya tu, yang you bagi saya tu. Apa namanya tu?
Fadzli.com je.
Betul. Yang you bagi saya nak tekan. Tadi saya dah tekan, mana pergi dia hilang pula. Okey, Fadzli. Tuan Z, saya nak masuk dalam ni. Saya nak kena buat presentation sekejap ke? Okey, Tuan Z. Okey. Mungkin tengah hari. Lepas tu. Okey, alhamdulillah. Dia jadi MC sekejap itu yang saya tak MC sekejap.
Kapasiti pun ada macam ni kita perlu. Saya pun gerak juga, mak saya nanya Prof.
Oh, dia tak duduk dengan ayah dia, dengan mak dia.
Mak dia duduk dengan dia, ayah duduk sini.
Kenapa macam
Ayah dia duduk dengan grup sekeliling tu adik-adik dia. Mak dia asalnya di Tarik Panjang sebelah Bali.
dia besar?
Dia kata tadi, tak tahulah mungkin orang tua-tua kan dia ada. Saya sendiri pun, saya lah lama tak dua-dua tak nampak. Mak dia umur 80 lebih.
So, ada orang kena
Adalah duduk dengan adik dengan kakak sebagai sebab kadang-kadang yang minggu ni saya pergi lah kan. Tengok-tengok lah. So, biasalah hidup kita kan. Itu. Selamat aku balik. Yang ni saya akan nanti yang saya clearkan. Macam saya pun dengan KPP tu saya kata saya bawa dulu. Saya tadi bawa. Saya bawa dulu. Tentu saya kata lah. Saya kata insyaAllah Prof dia lebih Prof writer, saya kata dia lebih kepada kerja. Dan
kita semua pun macam tu.
macam seorang perempuan tu. Dia buat PhD, dia tajuk saya dah saya bekerja.
Tu dah bekerja pula kan. Betul-betul.
Okay, Prof, boleh start kot.
Lambat. Sorry lambat. Tak boleh lah.
Boleh gambar.
Dah gambar, nak gambar. Okey, kat sini ke office.
Alright, Assalamualaikum ya. Ada masuk dah. Kita dah start ke belum ni?
Ada link ke dengan tu? Dengan Facebook?
Dah buka kan tadi? YouTube. Dr. Fadzli bahasa Malaysia ke bahasa Inggeris?
Sebarang. Both boleh.
English.
Bahasa Inggeris
English.
Okay.
Saya jemput India. Saya jemput daripada ni. International.
Nanti saya cakap dulu. Nampak berseri-serinya. Dr. Shira punya pipi glowing. Bila lah saya nak glowing macam tu. Saya dah tua dah.
Dah masa Facebook live.
Tengah live kot.
Oh ya ke? Astaghfirullahaladzim.
Okay, serius.
Shira boleh start.
Ya?
Boleh start. Shira MC kan? Perkenalkan Prof Sal.
Okay, Assalamualaikum and very good afternoon. So actually today we are very lucky. We have as a MYTRIBOS society, we have been held all the MYTRIBOS can share recently audience around the world if you are participates in this webinar. So without further the time, so I would like to invite Prof Samia to officially make it officially. This event is official.
Alright, Assalamualaikum. Thank you, Dr. Shira. Can you hear me very well? Alright. Okay, thank you. Right, thank you. Dr. Shira is our secretary number 1 for MYTRIBOS. This is actually, we are so happy to be able to organize the first webinar for this year. Yeah, the first webinar for this year. Yeah. Okay, now because we have COVID-19, for the pandemic, there will be a new norm. And as a society, MYTRIBOS has changed our strategy to have a webinar every month. Yeah, so it should start in January, but because of some constraint, we decided to start in February. And the first person to give a talk for MYTRIBOS webinar for February session is Associate Professor Dr. Fadzli. I'm going to read out his background for you to know him better. All right. Let me go to this one first. So, Associate Professor Dr. Fadzli received his Bachelor of Engineering Honours in Mechanical Engineering and Masters of Engineering Mechanical from Universiti Kebangsaan Malaysia. For those from other part of the world, Universiti Kebangsaan Malaysia is one of the outstanding research university in Malaysia. He also completed his Doctor of Engineering from Nagoya University, Japan. Yeah, from Nagoya University, Japan. Currently, he's attached to the Faculty of Mechanical Engineering at the Universiti Teknikal Malaysia, Melaka, UTM. Previously, he held various positions, including Deputy Dean for Research and Postgraduate Studies at FKM, Mechanical Engineering Faculty, UTM, Manager and Coordinator of Center of Excellence at the Center for Advanced Research on Energy, which is known as CARE, Head of Department, Diploma Studies at FKM, UTM, and Executive Member of Society of Engineering Education Malaysia, SEAM, Membership ID PO267, and he's also the Vice President for Malaysian Tribology Society, MYTRIBOS, and Deputy President of Asian Tribology Council, which is known as ATC. So his research interests include tribology of eco-material and surface engineering, and he has received Outstanding Paper Award 2017 by Emerald Publishing UK. In addition, he was recognized as the Outstanding Reviewer for Tribology International. For your information, Tribology International is a Q1 journal. Yeah, he received that in 2017, and Energy by Elsevier in 2018, which is quite outstanding achievement. He's one of the key pioneers in developing the green technology, green tribology and engine performance. The short name is G-Tribo in UTM. See, he's a member of CENG, Institution of Mechanical Engineers UK, member of Society of Automotive Engineers of Japan, and also a graduate member of Institute of Engineers Malaysia, IEM. Of course, he has, with this outstanding, he has a very a bright future ahead, and I believe that he's in his way to achieve his professorship, the highest sort of achievement as an academician. He's on the way to that, very near. Okay, without further ado, I would like to invite Dr. Fadzli to give his presentation. Please, Dr. Fadzli, over to you.
Okay, I will share my slide first. Okay, nampak slide Slide. Okay. Okay, thanks to Prof. Salmia for the nice introduction of mine. Actually, Prof. Salmia is actually our MYTRIBOS president and also a rector of the UITM Penang and also our Queen Mother of the MYTRIBOS. Okay. Okay, guys. Okay, today I would like to share our latest, what we call our latest research findings regarding the oil palm fiber and also the Canal as a new sustainable tribal materials. Okay. So that I believe that most people out there do not know what the exact meaning of the tribology is. Even actually some mechanical engineers do not know about the terms. Okay, so that but I think we know about the friction, wear and tear, and also the lubrication. And also actually by combining all these terms, the friction, wear, and also the lubrication, it's called tribology. Okay, so that the term of tribology is actually was coined by the professor, late Professor Peter Joyce in 1966, which is the 55 years ago. Okay, okay. Actually, tribology is interesting because tribology is related to our daily life. And then thanks to tribology, because without the friction, we cannot walk, and then we cannot sit on the chair. And then actually, without the friction as well, we cannot brush our teeth, and even we cannot eat the chocolate without the friction. As for the transportation, for example, for the cars are also unable to move without the friction between the tire and also the road surface. So now I hope everyone could everyone could appreciate the tribology more in our life. Okay, so that okay. Okay, let's back to our presentation today. Okay, my presentation entitled is Malaysian Agriculture Waste as New Sustainable Tribological Materials. And I'm also I am an associate professor at the Faculty Kejuruteraan Mekanikal Universiti Teknikal Malaysia Melaka, and also the vice president for the academic term of the MYTRIBOS. Now in the 2 terms. Okay, this is the some brief of my biography. I think Prof. Salmia has read my biography, so that I skip this one. Okay, this is the highlight that I will share you this evening, which is about the introduction, and then about the palm oil industry in Malaysia, and also the Canal industry in Malaysia, and then we go to the future application of the palm oil and the Canal in tribology, and then there are some experimental results that I will share with you under the dry sliding condition, which is the oil palm fiber versus Canal fiber polymeric composite, palm connectivated carbon reinforced polymeric composite, and lubricant impregnated palm connectivated carbon reinforced polymeric composite. And then the latest of our research, we call that oil palm fiber based graphene coatings. And then the conclusion lah. Okay. Okay, actually what is tribology? As I said before, the tribology is the combining of the 3 terms we call the friction, wear, and also the lubrication. Actually, the tribology is the ology or the sign of tribon. The words is come from the same roots as the tribulation. Okay, a faithful translation defines tribology as the study of grabbing or sliding. The modern and broadest meaning is the study of friction, lubrication, and wear, as I said before. And then what is actually the agriculture waste? The agriculture waste, which include both natural, which is the organic, and non-organic waste, is a general term used to describe waste produced on a farm through various farming activities. There is some activities that can conclude, but are not limited to dairy farming, horticulture, seed growing, so on and so forth. Okay. Okay, this is the popular, what we call the popular diagram, the popular map for the breakdown of the passenger car energy consumption in the world. This is actually this diagram or this map is actually published by the Homburg on 2012. He found that in passengers car, if we fuel the car with the 100%, so that actually about 30% of the energy will use for the friction losses. So that these friction losses actually we need to remove as minimum as we can by the technology developments, either using the new materials or using the new coatings and also using the lubricants. Now we call the nano lubricants lah. Okay, and then this is the chart, the chart from the STLE, the list of technology that will play a significant role in transportation industry through the long and short-term trend. It's about published on 2017. So that from this one, we can see that the higher demand for the next 5 to 10 years. We can see that the high efficiency vehicle is higher demand, low emission vehicles is higher demand, and then the lighter materials used in the vehicle construction is also the higher demand for the next 10 years, and also the longer lifespan for the car automobile parts. This actually related to the way and also the maintenance. So that by this one, we need to develop a sustainable bio-tribo materials. Okay, actually, there are two commodity plants in Malaysia. We call the oil palm and also the Canal. Actually, the oil palm is managed by the Malaysian Palm Oil Board, founded in 2000, and then the Canal is actually founded in 2000 as well, by the National Canal and Tobacco Board. Okay, now we go to the palm oil industry in Malaysia. Okay, this is what we call the palm oil is the largest source of residue, about the 70% of the total in Malaysia. And then from the Malaysia palm oil itself, they commit to minimize the release of harmful waste to the environment. And then today, the zero waste concept has become part and parcel of the industrial practice. Okay, this is the oil palm tree, where the Malaysia, the biggest producer, 11% of the world production, of the 27% of the export trade. So that from this oil palm tree actually created a major disposal problem. There is abundance of raw material available of the palm tree, consisting of around 90% of biomass waste and only 10% of the oil. This is the oil palm tree, only produce 10% of the oil, and then the rest, about 90%, is actually the biomass or the waste. Okay, this is the oil product and waste biomass obtained from the palm fruits and seed. That is about 52 million ton of the oil palm. We produce the palm oil, and then we produce the palm kernel oil, about 35 million ton, and then but the rest, about 35 million ton, is actually the waste lah, either in the form of the empty fruit punch, fruit fiber, or the palm kernel cake. This is the oil palm fruit. This is the endocape, and then this is the kernel, and then the mesocape. This is the term. Okay, now we go to the Canal industry in Malaysia. Actually, this is the Canal tree. The developing of Canal industry is reflected by two important events: the transformation of MNTB and Malaysia National Tobacco to Malaysian National Canal and Tobacco Boards. And the inclusion of the Canal industry as one of the strategic industries under the East Coast Economic Region Development Program. This is now the Canal is sowing and fertilizing using the fully mechanized to reduce the labor and also increase the yield. Okay, Malaysian government has taken the initiative to focus on the development of Canal product by integrating the upstream and downstream processing R&D towards the economic and marketing strategies. This is the morphology, the term of the Canal core, and then this is the sum of the mechanical properties of the available fiber, and then we can see that Canal has lowest density compared to others, and also around medium of the elongation, and then height, very high tensile strength, above 930 megapascal, and also very high the elastic modulus, about 50 gigapascal. Okay, now this is the future application of the palm oil and Canal in tribology. This is the some of the application that we could use our agriculture waste to be the water wheel bearing, to be the track brake, or in the miniature or instrument bearings. Okay, there are a lot of things that can use the Canal to be in a tribology parts. Okay, now I will show about some our research findings in our labs about the agriculture waste under the dry sliding condition. Okay, this is the typical test, a ball or pin on this of the tribology test under the dry sliding condition we use to test our material or our composite. Okay, this is the micrograph, scanning electron micrograph for the Canal versus the oil palm fiber. We can see that for the oil palm fiber, we can see that there are a lot of voids and also the debris and also the trichomes. And then for the Canal, we only see the debris without the voids. Okay, this is the same image from our laboratory. Okay, this is the result of the hardness of Canal fiber composite versus the oil palm fiber reinforced polymeric composite. And this is our sample. We use the pin form of the sample, and then this is the Canal fiber epoxy composite of the for the sample. So that we can see from this chart, from the hardness chart, you can see that oil palm fiber composite has higher hardness compared to the Canal composite. Okay, this is the oil palm fiber, the solid line, and then this is the dashed line is the Canal fiber. Okay, this is due to the formation of the void in the oil palm fiber epoxy composite, induced higher moisture, water absorption, and resulted in low hardness with respect to increased fiber content. Okay, this low hardness of the Canal fiber is due to the void. Okay, this is the result of the friction of the Canal and also the oil palm fiber action. And the trend is similar, which is the coefficient is reduced with the temperature. But then the coefficient decrease with temperature. This is actually due to the softening of the epoxy, and also the fiber started to burn out. And then we can see that by increasing the fiber content, the friction coefficient is lower. Okay, but then for the oil palm fiber is vice versa. By increasing the Canal fiber, by increasing the fiber, the coefficient of friction is increased. Okay, this is the result for the wear rate of the Canal fiber composite and also the oil palm fiber composite. Okay, we can see that Canal fiber composite has higher wear rate than oil palm fiber composite at higher temperature. This is at the lowest temperature. At the lowest temperature, the trend is same. At the lowest temperature, we can see that oil palm fiber is higher wear rate than the Canal fiber. But then at higher temperature, the oil palm fiber has the lower wear rate compared to Canal. This is the advantage of the oil palm fiber. That means that oil palm fiber can withstand with the high temperature, can withstand its wear at the high temperature. Okay. Okay, this is the wear map. Okay. This is a wear map of Canal fiber composite versus the oil palm fiber reinforced polymeric composite. This one is the Canal fiber. This one is the oil palm fiber epoxy composite. from this wear map, we can see that there are two types of the wear transformation, which is the from mild wear to the severe wear. And then we can see from this both of the wear map, we can see that all palm fibers, epoxy composite has better wear resistance than the canal fiber epoxy composite, because we can see that the severe region is smaller than the severe region of the canal fiber. Okay. Okay, this is the failure mode of the canal fiber. We can see that there are some debonding, and then where is the debonding? DE. Okay, some debonding, some delimitation, and then the torn fiber, broken fiber, and also the fracture of the fiber. Okay. In the mild wear region, we can see only the micro crack and also the fine groove, because of the gouging. Okay. Okay, this is the oil palm fiber reinforced composite wear failure. Basically, the wear mechanism or the wear failure of both composites is the same, is similar. Okay. Okay, now we go to the palm kernel activated carbon. Okay, actually the palm kernel activated carbon is actually the what we call the form of the atomic of the graphite, and also the palm kernel activated carbon is similar. Okay, but then the palm kernel activated carbon, or we call the PKAC, have a disorganized form of graphite. Okay, actually the kernel, this is the kernel, the kernel, and then we extract the kernel, and then we use the chemical process to make the activated carbon. This is the activated carbon from the kernel. Okay. The structure of the palm kernel is similar to the graphite. Okay. Okay. This is the map for the palm kernel activated carbon. We can see that at higher temperature, the coefficient of fission and also the wear rate of the palm kernel activated carbon composite is also increased. And then we can see that the hardness is also decreased with the temperature. This is most likely due to the soften of the epoxy itself at high temperature. Okay, now at the high temperature, we can see there are some cracks at the composite surfaces. Okay. Okay, this is we compare our composite, our agriculture-based composite with other agriculture-based polymeric composite, and also the commercial composite. You can see that this is the palm kernel, this is the canal fiber composite, and then this is the oil palm fiber composite. And we can see that this palm kernel activated carbon, the friction coefficient is I emphasize at the room temperature, because at the high temperature, the coefficient of friction and also the wear rate is increased. So that at the room temperature, we can see that the friction coefficient of the palm kernel activated carbon is similar to this graphite. Okay. Above 0.2 or 0.3, because we test at the under dry condition, and we when we test under lubricated condition or water condition, the coefficient of friction can be lowest as a 0.1. Okay. Okay, this is the wear rate. We can see that the wear rate of palm kernel activated carbon is the lowest among other agricultural waste-based polymer composite, and also the commercial composites. We can see again the wear rate is also similar to the graphite. Okay. Okay, this is the wear map for the palm kernel activated carbon composite. We can see that increasing the value of the contact pressure, this wear map is as a function of contact pressure between the sliding speed and also the contact pressure. by increasing the value of the contact pressure led to the severe wear. This is the contact pressure. By increasing the contact pressure, okay, did the severe wear. At higher level of sliding speed, this one at higher level of the sliding speed, the transition from the mild to severe wear occur at lower contact pressure. Okay, and then however, after 400 RPM, this one, a considerably slow change of mild to severe wear occur where the composite material show better wear performance. Actually, the wear map is beneficial for the material engineer or design engineer to what we call to fabricate, to produce the product without a prior failure. Okay. Okay, now we go to lubricant impregnated. Okay, this one is actually the pump connectivated carbon without the impregnated, and then we test that composite by impreg this composite into the lubricant. Okay, and then we want to know about the finding, the results. Okay. Okay, why we need lubricant impregnation? From this one, from this chart of Richard et al. 2019, we can see that the premature bearing failure is most due to the poor lubrication. Okay, in bearing, external lubrication raise issue of lubricant tanning, which is non-degradable waste. To minimize or eliminate this issue, there's need for biotribal material with limited or no external lubrication, or with with self-lubricating its abilities. That's why we use the term of lubricant impregnation. Okay, and it means that we impreg the lubricant into the void of the in the composite itself. Okay, this will particularly be interesting in pre-lubricated system where the friction member absorb the lubricant during the intermittent flow and maintain it over a long period will be necessary. Okay, this will not only lead to a reduction in friction coefficient, but also reduce the amount of lubricant used in the system. Okay. Okay, this is the result. We can see that this is the composite without impregnated, without impregnation with the lubricant, and we use three types of lubricant, which is the water, paraffin oil, and also the palm oil. We can see that the water impregnation, we can see that there are some sudden increase of the friction coefficient when we arrive around 200 meter. Okay, but then for the palm oil and paraffin oil, we can see that coefficient of friction is quite similar. But then what we can see from here that the unsoaked or non-impregnated of the composite, the coefficient of friction is larger than the impregnated composite. Okay, this is we soak the composite 1 day. After we soak 1 day, and then we take out the sample, and then we dry the sample, and then we test. Okay. Okay, this is the coefficient of operation of water impregnated pump canal by water impregnated. Actually, this is the first test. We soak at 1 day, and then we dry, and then we test. And then after the test 1, we dry again. With additional 1 day without any impregnation, and then we test, and then for the test 3, we dry again for additional 8 days, and then we test again. So that this is the result. We can see this is the answer for as a datum. This is the first test. Okay, this is under the water lubrication. This is the first test, and then this is the second test. We can see that there are not much of the different of the coefficient of friction. But then after the third test, which means after the 8 days without the further impregnation, we can see that coefficient of friction is increased. This is might be due to the evaporation of the water in the air. It means that the sample does not have enough lubricant. Because of the water evaporation. Okay, this is in the paraffin oil. We can see that even after the test 3, which is after we dry for additional 8 days, the coefficient of friction is still similar. is about 0.006. In water, still about 0.06, but then after the test, we can see that the coefficient of precision increase about 0.008. Okay, and then this is impact in the pump oil. We can see that when impact the pump oil, the coefficient of friction is lower than when impact with the paraffin. We can see that about 0.04. The coefficient of friction when we impact with the pump oil, the coefficient of friction is 0.04. But then with paraffin is 0.006. So that this is the advantage of the pump oil. Okay, this is actually the average, the summarize of the coefficient of friction for these three graph. And this is the summarize. We can see that for the unsoaked coefficient of friction is about 0.12. And then when we soak in water, that has increased after we keep in this without further impregnation is about 0.08. And then for paraffin oil, the trend is decrease. So that about 0.04. And also for the palm oil, 0.06 for the palm oil, we can see that the trend is suddenly decrease. And then the coefficient of friction, we can achieve the coefficient of friction about 0.004. Okay, this is the weigh rate. We can see that. But then the weigh rate is increased after we soak with the lubricant because of the hardness. When we soak with the lubricant, the hardness will what we call will decrease lah. Okay. Okay, this is the weight loss. Soak for 1 day and kept 2 days and 8 days without further impregnation. We can see that the weight loss when we soak in palm oil, there is not much different in weight loss, which means that the lubricant is still in the pore or in the void of the material. And then we can see that the hardness, even we soak, the hardness is a bit reduced by soaking. Okay, now we see the oil palm fiber based graphene coating. Okay, this is actually our latest research, our latest finding. We use the oil palm fiber as the carbon feedstock for the graphene coating. This is the graphene coating on the copper substrate, and we use the CVD method. CVD means chemical vapor deposition method, and then we successfully grow the graphene on the copper substrate. This is the graphene OPF graphene, coated graphene, and then this is the uncoated. This is the naked copper lah. And then when we compare our graphene with other studies that grow the graphene using the commercial feedstocks like the hydrocarbon, and then we can see that our coefficient of fission, our graphene is most likely lower than others, and also the weigh rate. Okay, this is the stress testing. We can see that this is the substrate of the copper. We can see there are lots of wear with that here, but then this is for the graphene. Okay. Okay, as a conclusion, actually this map is from the Friedrich et al. 2018. The map is expansion of the specific variant and also the coefficient of friction. And we can see that with all this is the dry sliding. This is the application. With all the application is for bearings. For bearing needs the coefficient of friction less than 0.4, and then the specific variant must be less than 10 power of negative 4. And then if the variant is larger than this value, and then the coefficient is larger than 0.4, the suitable application for this material is for the brakes. So that the oil palm fiber and canal fiber reinforced polymer composite The future application is for the brake, but then for the pump connectivity carbon and reinforced polymer composite, the application is more suitable for the bearings. Okay. Okay, that's all. Now I give the stage to the Prof. Salmia to end up this session. Okay, thank you very much.
Okay, thank you so much, Dr. Fadzli. That is very indeed a very informative and very interesting research that you have. One thing, because you can turn waste into wealth. And this is one of the national agenda on having a project which can turn the waste in the country into waste, into wealth. Yeah, Alhamdulillah, that is really, really very good. And then I'm also keen on the last part of the presentation on the self-lubricating, as we also in UITM are looking at metal. We are looking at metal oil impregnated, but you are looking like a composite, and that is very, very exciting lah. Yeah, I think you can go further with that experiment. Do we open for any question? No? No, okay. So for this session, we will not open for question, but if you have some interest and you want to know more about what has been presented, please kindly contact Dr. Fadzli directly. And also for the industry people, if you're watching, you can also contact Dr. Fadzli for a possible collaboration into producing actual material component which can be commercialized. Yeah, Dr. Fadzli is relatively young and he's very energetic. He's not only energetic into his research, but he's also a very active contributor. Yeah, contributing person in the in MYTRIBOS. Yeah, MYTRIBOS. He's very active, actually helping out in so many ways, including the conferences and many more. Congratulations, Dr. Fadzli. You are the first. Yeah, you are the first to participate or to give out in this MYTRIBOS webinar, and then we will have one presenter every month starting from this month. So we will announce it earlier, at least 2 weeks earlier. Yeah, and I hope you will come again, will join again our webinar. All right, that's it. I will pass over to Dr. Shira. Are you there, Dr. Shira?
Shira ada.
Okay, Dr. Shira has left, so I will close this, and I hope you have benefited from this sharing, and of course we will meet you again next month. Thank you again. Bye-bye. Assalamualaikum. Thank you.